8M6 Lesson 6, Scatterplots. Today we're going to talk about graphing two pieces of data against each other, two variables, also known as bivariate data. Let's get going and take a look. Okay, wait a minute. I just want to make sure you're seeing what. Let's make sure we're seeing the same thing. Yeah, we are seeing the same thing. Okay, so what we're going to do today is we're going to learn how to build a scatter plot, and then how to identify a possible statistical relationship, well, in the scatter plot, or also, between the two variables. So let's talk about some terms. A scatter plot is a graph containing numerical data on two variables. So we're going to have these data charts, these t-charts, with two variables like x and y. And this is similar to what we've seen before. So when we talk about two variables, we can also call that bivariate data, because two means bi, or bi means two, and variable, another word for that is variate. So sometimes you'll see this thing called bivariate data, and that's what we're talking about, all the examples today. And I'll talk maybe a little bit and maybe use this word so that you really get a sense of what bivariate data is. That's one. Number two, definition number two is statistical relationship. So sometimes bivariate data, when you graph it, there is a statistical relationship. And they will see an existence of a connection between the two variables, such that as one increases, the other will increase, or the other will decrease. This would be a statistical relationship. If as one increases, the other doesn't tend to increase or decrease, that would be not a statistical relationship. We'll talk a little bit more about this as well. And note, whenever we have a statistical relationship, it doesn't prove that increasing one variable will cause the other to increase. Sometimes it does. Sometimes increasing one causes the other to increase, and that's a causal relationship. Otherwise, we just have this thing called a correlated relationship. When one goes up, the other one tends to go up, but they don't cause each other to go up. And I'll give you a good example of that later on. Hopefully make it really clear. Okay, so let's now start with an example of a scatter plot. In today's lesson, we're going to simply use the book. The book or the handouts were very good, gave good examples, and so I'm going to stick to that today rather than come up with my own examples. So here we have the example from the book, and it talks about these 20 or 13 car models that Chevrolet makes. These are car models that Chevy made in 2009, and we look at the weight in pounds of each car. So some are bigger cars. This would be a bigger car, a 5,600 pound car, and a smaller car would be this one, this 2,550 pound car. And then we connect the weight, the fuel efficiency of that car to the weight. So this 2,550 pound car, this smaller car, gets 28 miles to the gallon. This 5,600 pound car gets only 16 miles to the gallon. The higher the fuel efficiency, the farther you can go on a gallon of gas. So let's go ahead, and we are going to chart, or we're going to graph this chart. So let's look at the weight of each car, and we're going to graph it versus fuel efficiency. So here's our X, and here is our Y. And so we know how to graph this. 3,200, 23 is right here. So let's go 2,550. 2,550, 28 is about here. So we got 1 and 2. So let's look at 4,050, which is about right here, and 19. Something about right there. 4,050 again, and then 20. We have two cars that weigh the same, and one gets a little bit more than the other. So notice this is not a function because we have two values at 4,050, and we got two values. So it's not a function. That's okay. Bivariate data does not, we're just building what they call a scatter graph. Or scatter plot. We're just putting down a bunch of data points. So 3750 right here, and 20. 3550 and sorry, that was 3550, something right about here, and that's 22. 3550 and 19. 3,500 and 25. So there's one here that comes up to 25. 4,616. So all the way over here in 16. 5250 and 12. 5250 and 12. Wow, 12, not very much. 5,616. 4,516. And then 4,815. So that's all 13 points, and they're pretty close. I may not have graphed them perfectly, but that's okay. The idea of a scatter plot, and if we had to be perfect, I probably would have taken a little bit more care, but they're pretty close, these points. So let's see, do we notice a pattern in the scatter plot, and what does this imply about the relationship between weight and fuel efficiency? Well, let's look at this. Let's look at a few versions, a few lines that might fit this data. So that's what we're looking at when we're looking at a pattern. We're kind of looking at, as one goes up, do we think it goes down? Do we think that's a good match? Do we think as we go, does it go up? Well, that doesn't look like a good fit. We're trying to find a line where everything is pretty close to the line. Maybe this, something like this, because all the points here tend to be a lot closer to the line. The other thing you could have is you could actually have a flat line like this, but in this case, they're not really, the points are not really that close. They are in the middle, but not on the sides. So what your eyes can catch, because you've plotted this data, is that this is probably a good fit for the line. Later on, we might show some better ways to find the line, and there's some tools that will show you best fits for line, and some math you can do, but we're not going to learn all of the math in 8th grade as to how to find this line. But what we are going to allow you to do is just say, hey, this line goes down as the weight increases. So the pattern in the scatter plot that I noticed, and then hopefully you noticed, is that as the weight, which is x, this is our x, increases, our fuel efficiency y decreases. Okay? That's the pattern. You can kind of circle all the points like this, and then you can draw a line down the middle of it. That's another good way of making sure of identifying what the pattern is. So what does this imply about the relationship between x and y? Well, it implies that as the weight increases, our fuel efficiency decreases. Okay, so that's all we're trying to do, is we're trying to see, one, how to graph data, and two, how to identify statistical relationship. And there is a statistical relationship. We're pretty darn sure that there is one. Okay, because it goes down. As one increases, the other goes down. If it increased, there would also be a statistical relationship. Okay, let's look at another example. Okay, so now we're talking about the quality of shoes and the price of the shoes. So the price is our, in this case, we're going to, let's just change up colors just because I like to. This is our X and this is our Y. And so this is our X and this is our Y. And so let's see what would be a reasonable choice of scale for the Y-axis. Well, let's see, we want to make sure everything fits over here. So we want to, let's see, our lowest is 51 and our highest here is 71. So maybe let's make it go from 50 to 75. Let's try that. And then notice here we have a break. So we're going to do a break here. And then we're going to start at 50. But we can't break in the middle. We have to, once we start here at 50, and all of our data points are between 50 and 75, we pretty much have to stop. We can't put any more breaks in. So here's our 50. We're going to call this 50. 1, 2, 3, 4, 5, 6, 7, 5. Wait, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And you know what I'm going to do to make this actually a little bit easier? Let's just go ahead and let's make some nice skinny lines that go across here so that we can, it'll be easier to make our points. Wait, why did it not change it to, we want our line width to be 1. There we go. There we go. $65, 60, 55, and then 50. There we go. All right. So now let's make our lines be fat again. Okay, good. All right, so let's plot our points. We know how to plot our points, and let's plot them maybe in blue. So 65, the idea here is we're trying to see if there's a correlation between price and quality. That's what we're trying to see. And I'm trying to actually go back to my pen being 3.5. Okay, good. So is there a relationship between price and the quality of shoes? I'm trying to find out if I spend more money, am I going to get a higher quality shoe? And I don't know the answer. So let's see. The price, 65, gives me a 71. 45 gives me a 70. I have a $45 shoe that also just gets a 62. I have an $80 shoe that gives me a 59. I have a $110 shoe that gives me a 58. And one that gives me a 57. So we've done all of these points. A $30 shoe that gives me a 56. An $80 shoe that gives me a 52. A $110 shoe that gives me a 51. And then a $70 shoe that gives me a 51. So we've done that. Our scale was 50 to 75. We've constructed a scatterplot, C left. Now, do we see a pattern in the scatterplot indicating a relationship between the price and quality of athletic shoes? So here's what we want to do. One way to do this is we can kind of make a little dotted line around all our points. And see, well, what kind of line would go down the middle of this one and make it kind of be a nice fit? Well, I think it would be kind of like something like this. A line that would go like this might be the closest line to all the points. So it certainly wouldn't be one that goes upwards. It's got to be one that kind of goes downwards a little bit to fit all of these points pretty well. So what do I see? Do I see any pattern? I would say yes, a slight decrease in quality as price increases. Right? In other words, as I get higher in price, as I get higher in price, it looks like I go down in quality because I have these points over here for expensive shoes, and then for cheap shoes, I have these points over here. So I have some low quality cheap one, but some high quality cheap shoes too. And then all of my expensive one are low. So it seems some people think that shoes have a high price. They must be high quality. So what would you say? Just pause and think about what you'd say. Pause the video. Okay, now I assume you're back. And I would say the answer is no. Because my data, and this is from Consumer Reports, a very popular magazine for quality of items you can buy, from Consumer Reports shows high quality high priced shoes with low quality and no high priced shoes with high quality. Right? All of my high priced shoes have low quality. I don't see anything up here. I don't see a $110 shoe with a 75 or a 70. The only shoes that I see with 75 and 70 quality are either $40 or $65 shoes. So we're learning how to interpret data. This is very powerful. Let's look at one more example. And this is between shoe size and score on a reading ability test. So we've taken a number of kids and we've taken their shoe size, and then we said, well, what is their reading score? And so kind of the question is does there appear to be a statistical relationship between shoe size and the score on the reading test? Let's do our little circle the data test. And now we'll see. It looks kind of like, well, yeah. It looks kind of like there is a relationship. It does look like as shoe size gets bigger, the reading score goes higher. So I would say, yes, it appears that higher shoe sizes statistically relate to higher reading scores. Yes. So that's the answer to A. Now the question to B, or to number 9, I should say. And now the question on number 10 is, explain why it is not reasonable. So we're getting the answer. Why is it not reasonable to conclude that having big feet causes a high reading score? I want you to pause and think about that. I want you to pause the video and think. Pause the video and think. In other words, is there another reason that we might see this pattern? Okay, so hopefully you're back, and hopefully you came up with a few ideas. I'd love to hear them, but I can't because I'm just talking in one direction. So one good answer might be that, older students have bigger feet, and older students have more education. So again, we have older students who have bigger feet and they have more education. And so all of those students are going to have better reading scores. So do you think that they have better scores because they have bigger feet, or probably because they have more education? And I think it's probably that they have more education, but we don't have any data at this point that can prove it. Okay, let's move on to our summary. So what did we learn? We learned that a scatter plot is a graph. A scatter plot is a graph of numerical data on two variables, which is also called bivariate data. A pattern in a scatter plot suggests there may be a relationship between the two variables. So remember how we identify patterns. If we have some points that tend to go up, we can draw a circle around them and kind of see that they go up, or we may have data that tends to go down as we get higher. These would be statistical relationships. An example where there would be no statistical relationship might be something like this, where as one gets higher, the other one doesn't change. So this would be yes, this would be yes, and this one would be no. Again, as this one is, the x gets bigger here, the y doesn't change. It stays pretty constant. So that would be not. And these would be, we'll just turn those into yeses. So if two variables tend to vary together in a predictable way, there is a statistical relationship between the two variables. Again, that's yes and yes. And a statistical relationship between two variables, this is what we learned in the last slide, does not imply a change in one causes a change in the other. It may not be a cause and effect relationship, like the shoe size. Let me give you one more example. There was this example that people took data. There was data on a beach in Florida. And it showed this. It showed that as temperature, no, it showed that as, I gave you the hint, as ice cream sales increased, there were more lifeguard rescues. So the question is, does this mean that if you sell more ice cream, that you're going to get more rescues? And the answer is this is clearly a relationship but increasing sales will not increase rescues. In other words, if I start selling way more ice cream, I'm not going to get more increased rescues. What do you think was going on? What do you think actually was happening here? Well, the deal is that when temperature increased, more people were at the beach. And so more people, and they proved this later, more people means more ice cream sales. And more people means more people in the water, which means more rescues necessary. Right? So sometimes we can show relationships occurring, but clearly more, selling more ice cream doesn't mean more rescues. And the temperature and the more people at the beach is the thing that explains that relationship. We're going to do more of this causal and correlative scatterplot stuff in lessons to come. Hopefully you stuck with me. Hopefully this made sense. Hopefully it was useful. And I will see you next time here on Dave Lipscomb's math channel. I will, hopefully we're loving math. We only have, I think, 8 more times together. But the good news is the year's almost done. So enjoy the last 8 lessons of 8th grade math. We'll see you next time with 8M6, Lesson 7 here on Dave Lipscomb's YouTube channel.